Okay, this is differentiation with the chain rule. Okay, so there's an inside function, and that's then another function is being applied on the outside of that. Now, the long method is to give the inside function a name, u. So the inside function here, inside the brackets, I've got u would be 3x plus 4, so that y is that inside function to the power 5, so that's u to the power of 5. So if we're using the long method, we have to introduce a u, and we need y in terms of u and u in terms of x. Okay, and then we have two easy differentiations to do. So differentiate u to the power 5, we get 5u to the power of 4, but this is incomplete. We need to give this its name. Really vitally important we use the correct notation. So this is dy by du, because we've got a y where it would normally be, we've got a u where the x would be. And when we differentiate this, we've got a u where y would normally be, we've got an x where it would normally be, so we're going to get du by dx here, not dy by dx. And if I differentiate this, I just get 3. And then the chain rule says that if I want dy by dx, then I do dy by du times du by dx. Okay, because we can kind of visualize these du's cancelling. It's a little bit more to it than that, but that's how you can remember the chain rule. So I have to do my dy by du times my du by dx. So that's 5 times u to the power of 4 times du by dx, which was 3. Now why have I put a bracket instead of u? Well, I can't leave u in my answer. I have to leave my answer in terms of x, so I have to go back to what u was. This is 5u to the power of 4, but that u is really 3x plus 4. So 3x plus 4. So tidying this up, 5 times 3 is 15, so the answer is that dy by dx equals 15 brackets 3x plus 4 to the power of 4. So that's how to do it, and you may find that reliable. I call that the long way round, because what I can do is think about the inside function and the outside function. So the way I describe this to myself is I say the inside function is 3x plus 4, and the outside function is a bracket to the power of 5. It's really important you describe that using the word bracket. So the inside function, 3x plus 4, I differentiate that. So in my head, I can say dy by dx equals, differentiate the inside function. The inside function is 3x plus 4, so it differentiates to 3. It's going to be multiplied by differentiating the outside function. Now the outside function is bracket to the power 5. I'm no longer interested in what was in the bracket. So what does bracket to the power 5 differentiate to? Well, I know that x to the power of 5 differentiates to 5x to the power of 4. So, by analogy, bracket to the power of 5 differentiates to 5 times bracket to the power of 4. And notice, to write this step down, I haven't thought at all about what was in the brackets. This was the derivative of the bracket, but this part here is just the derivative of the outside function. Bracket to the power of 5 goes to 5 bracket to the power of 4. What's in the bracket? What's inside the bracket doesn't change, so it's just still 3x plus 4. Okay, I don't need to write this down. So therefore, I've written down this answer. That's not 3.5, that's 3 times 5. And if you notice, I've written down the same answer as I got for the long version of the chain rule, but I've just written it down straight away. Okay, so for all of the questions in this, we could do it the long way, we could do it the short way. So for part B, let's start off with the long way. So the u is the inside function. So my u is going to be 2x minus 1. What do I do with that u to get y? Well, I have to form y by doing e to the power of u. So I can get dy by du. dy by du, rule for differentiating e to the power of anything. E to the x differentiates to e to the x. E to the u differentiates to e to the u. Du by dx differentiates to 2x minus 1, just differentiates to 2. So my dy by dx, chain rule says that is dy by du times du by dx, which is e to the u times 2, and e to the u, I have to decode that u into a 2x minus 1, so, and put the 2 in front, so this is 2 e to the 2x minus 1. Or I could do it the quick way. Doing it the quick way, I'll do it in a different colour. Okay, going straight from this, I can say, what's dy by dx? Well, I need to find the inside function. The inside function is 2x minus 1, differentiates to 2. The outside function is e to the power of bracket. What does e to the bracket differentiate to? Well, e to the x differentiates to e to the x. So e to the bracket differentiates to e to the same bracket. What's in the bracket? Well, the bracket had 2x minus 1 in it, so it still has 2x minus 1 in it, and I've written down the correct answer straight away. Okay, so this one. All right, part C. Now here we need to do the same as we did in core 2. We've got a square root going on. We know from core 2 that we can get a square root by using a power of a half. So that's what I do. I have to rewrite this as bracket to the power of a half. Okay. Long method for the chain rule is inside function, inside the bracket I've got 3x minus 2. My outside function y equals u to the power of a half. dy by du equals a half u to the power of minus a half. Take one away from the power, multiply by the old power. And du by dx equals, this differentiates to 3. So I'm doing dy by du times du by dx, which is what the chain rule says I have to do. It gives me a half u to the power of minus a half times my 3, but u to the power of minus a half, this is 3 over 2. 3 over 2 times a bracket to the power of minus a half, okay, where the bracket is u and u is 3x minus 2. Or, quick way, I still have to do this first step. Inside function 3x minus 2, so dy by dx. First bit is differentiate the inside function, I get 3. Differentiate the outside function, bracket to the power of a half, differentiates to half bracket, and the new power will be a half minus a half, minus 1, which is minus a half. So it's 3x minus 2 still in the bracket, so I get to the same answer quicker. Going on to part D. Now part D is a log, and I'm going to be wanting you to learn a special rule for dealing with logs, but let's, on this one occasion, okay, just do it with the chain rule. Okay, I'm going to go straight to the quick version of the chain rule. So dy by dx equals, inside function 4x minus 2 differentiates to 4. Outside function is log bracket, but we know that the rule, our new rule for differentiating log of x is log of x differentiates to 1 over x. So log of bracket differentiates to 1 over bracket. So I get 1 over 4x minus 2 on the bottom. Okay, so simplifying that answer is going to be 4 over 1 times 1 over 4x minus 2, which is 4 over 4x minus 2. Okay. But this illustrates the rule that I want you to use for differentiating logs, which is I get a fraction, and on the bottom of the fraction, I get the function that was inside the log. So if I call this log of, if I call the thing inside the log f of x, so f of x is my 4x minus 2, it's my inside function. That inside function crops up again on the bottom of the fraction, so that is an f of x on the bottom of the fraction. And the top of the fraction, where did that 4 come from? Well, that 4 came from this bit, which was differentiating the bracket. So that is the derivative of f of x, which we call f dashed of x. So the rule that I am going to want you to learn for differentiating log of f of x is that when you differentiate that, it goes to a fraction with f of x on the bottom, that's whatever was inside the log, and then we differentiate this, so whatever is on the bottom of the fraction, you differentiate to get the top of the fraction. So that is a rule to make a note of and learn. Make sure that you've got a version of that rule in your notes. You can pop it on the previous page where you've got that summary of your differentiation rules. It's only got the very basic ones there, but you can add to this list here, okay? Along with all of these, we can refine this. So this rule here for differentiating log of x is not really very interesting. Differentiating, so if y equals log of f of x, okay, you want to make a note that dy by dx equals f dashed of x over f of x. Okay. All right, onwards with the exercise. So the next one is, okay, this is a very simple example of a cos. This is actually just a constant times x. So the way to look at this is we've got 3 times cos of something times x. So they've tangled x up with a fraction, but really this is just 5/6 times x. And that makes it a very simple, I mean, I don't think this is really the chain rule. I think you need to be able to differentiate something like this on site. So I certainly would never use the long version of the chain rule. What happens? Well, I've got an inside function of 5/6. So my inside function differentiates to 5/6. And then I've got 3 cos of bracket. What does 3 cos of bracket differentiate to? Well, we've got a new rule for differentiating cos. Cos of bracket differentiates to minus sine of bracket. So 3 cos of bracket differentiates to minus 3 sine of bracket. Okay, what's in the bracket? 5/6 x. Okay, so if you look at what we've done exactly what we would have done if we'd just had 3 cos x, except because there was a 5/6 in front of the x, we've got an extra factor of 5/6 popping out. And that gives us a rule for differentiating sine or cos of a constant times x. So if we've got this rule, this is great as far as it goes to differentiating sine x, it becomes cos of x. But if y equals sine of kx, then dy by dx will be something very similar. It will be cos of kx, but what will pop in front? Answer, okay, a k will pop in front because the inside function kx differentiates to k. And similarly, if y equals cos of kx, then dy by dx will be, well, if without the k, it just goes from cos x, it goes to minus sine of x. So I'm still going to get a minus, I'm still going to get a sine, but if I've got kx inside, then a k pops in front, and I get minus k sine kx. And the same thing happens with e's. If y equals e to the kx, then dy by dx equals, it still goes to e to the kx, but because the inside function has got this factor of k, we get a k popping in front. So I think that these are worth memorizing separately, okay, so that you don't need to resort to the chain rule for any of these examples. Okay, there was one last part of the question. Okay, so this one here, I can see e to the 2x, but it's on the bottom of the fraction. So what we have to do here, this is the same kind of thing when you had to differentiate things like 1 over 2 root x in core 2. Okay, you had to recognize that this involved a negative fractional power of x, and that this 2 was just kind of getting in the way, so you had to split this into a fraction with numbers, which is a half, times 1 over root x, which becomes a half, and then this you rewrite as x to the power minus a half, and then you were ready to differentiate this. So this is just an illustration. Obviously we've got to do it for this example here, but we can use the same method. So y equals, first of all, let's deal with this pesky 4 on the bottom of the fraction. We can split off a fraction with numbers 1 over 4 times our fraction with x's, which in this case is going to be 1 over e to the power of 2x. Okay, so y is a quarter, okay, e, and to get 1 over e to the 2x, I need to do e to the power of minus 2x. Okay, so now I've got e to the kx. We've just looked at a rule for e to the kx. We know a minus 2 is going to pop out. So, okay, I'm going to get minus 2 times a quarter e to the power of minus 2x. Okay, because e to the kx differentiates to k e to the kx, and I've got another factor of a quarter going on. Thinking about it the chain rule way, the inside function is minus 2x. Differentiate the inside function, I get minus 2. So that's where this comes from. And then the outside function is a quarter e to the bracket. Well, e to the bracket differentiates to e to the bracket. A quarter e to the bracket differentiates to a quarter e to the bracket. So we can see that this is exactly what we'd get if we did insist about thinking about it as the chain rule. Okay, so the answer is, simplifying this, minus a half e to the power of minus 2x. Alright, quite a bit going on that page, and this is something that you really need to practice the chain rule, okay? If you do practice the quick method, then it does become easy, okay? If you want the security of the long method, then it will work every time, okay? But if you're sticking with the long method, then you definitely want to learn these as separate rules, okay? Because you don't want to be invoking a big long version of the chain rule for things like these ones here. Okay, I hope that helps.